Diffraction is a wave phenomenon, occurs with all waves. Here's ocean waves coming from the ocean out there, and they go through this small opening, and they appear to spread out as they go through the opening. The waves appear to be bending around corners. One of the phenomena that you're probably familiar with is the fact that stars appear to have points in pictures of stars. They don't really have points, but when light enters the camera aperture, it spreads out. It kind of bends around the edges of the aperture, and so you get this distinctive pattern downrange. This also happens in your eyeballs, and so stars appear to you to have points on them. Not quite like this, but in a similar fashion. Here's a picture taken through a thin curtain, which has a simple weave of vertical and horizontal threads. So the light is effectively going through a lot of little square holes, and the way the light waves propagate through the square holes, they go downrange and they constructively and destructively interfere with each other to give you this distinctive pattern. In the exercise, you'll use this simulation. You push this button and it makes a plane wave that propagates toward this slit. When the wave propagates through the slit, you get diffraction and you get this spreading pattern downrange. The reason this occurs with waves is that along this opening, every point on the wave front acts like a point source of a wave, and these infinitesimal point sources, the way they add up downrange, the way they interfere with each other, gives you the pattern downrange. You'll study interference by looking at double slit diffraction. Here the waves are going through two slits, and the two waves emanating from the 2 points interfere with each other downrange. So where peaks meet peaks, right at the center of the pattern, you get a tall wave, and where peaks meet peaks out here, you get a tall wave, but right in between where a peak meets a trough, you get no wave. It's kind of a node right there where there's no wave. So this wave interference, this is the reason why you saw these phenomena that I described earlier in those photographs. The angles at which you get bright peaks, where peaks from one source add constructively to peaks from the other source, are predicted by this equation, d sine theta equal n lambda. And you're going to use this equation a couple of times to predict this angle. D is the distance between the slits. Lambda is the wavelength of the wave involved. Theta is the angle from the center line that the peak occurs. So for this central peak, m equals 0. And for this peak right here, m equal 1. And if there are more peaks, m equal 2, 3, 4, and so forth.